Okay, so here we are. This is our wonderful lesson for today. We want to use summation notation to write sums of finite arithmetic series. Now again, that word is pronounced arithmetic when we're looking at series or sequences, right? When we say arithmetic, that's when we're just doing our basic, adding, subtracting type stuff. So arithmetic. Now, if the series has very few terms, it's relatively easy to find the sum. So for example, here, I'm like, hey, there's only 6 numbers in the list, right? As n goes from 1 up to 6. So if I plug in the number 1, 2 times 1 is 2, take away 1, I get 1. And then if I plug in 2, 2 times 2 is 4, take away 1, you get 3. If I plug in 3, 3 times 2 is 6, take 1 is 5, etc. And then finally, the last number I plug in is 6. 6 times 2 is 12. 12, take away 1 is 11. And so those are the numbers I have to add up. 1 plus 3 plus 5 plus 7 plus 9 plus 11. And we can quickly figure out that the grand total is 36, and so that is the sum of that series. Now, what if instead of going from 1 to 6, I went from 1 to 38? What if there's 38 numbers in that list? Right? Or 38 terms if I want to speak like a mathematician, right? Normal person would say 38 numbers in the list. Mathematician will say there's 38 terms in the series. Well, if I plug in 38, 2 times 38 is 76. 76 take away 1 is 75. I'm like, oh my goodness. So the last number is 75. So I'd have to do 1 plus 3 plus 5 plus 7. Keep going until I finally get to that plus 75 at the end. And truth be told, I'd be a little worried about making a mistake, right? Because I know I've done it where I've typed in numbers to a calculator, I hit equals, I get an answer, and I've got the wrong answer. I'm trying to figure out how do I get the wrong answer? Well, I'm saying, well, maybe I typed it in to the calculator incorrectly, right? There's a chance that if I've got to type that many numbers in a calculator that I might make a mistake. It's going to take me a little bit of time. But then at some point, I'm going to realize, this is just not possible, right? If I start with the number 1 and I have to go to 40,000, think about 40,000. How long is this list, right? No one, and I mean no one, is going to carefully add up by hand a list of 40,000 numbers. You're just not going to do it. How big is 40,000? Well, 10 hours is 36,000 seconds, right? There's 60 seconds in a minute, 60 minutes in an hour. So if I had 10 hours, that's only 36,000 seconds. And you're thinking, well, gee, I could do 1 plus 3 plus 5 plus 7. Okay, maybe at the beginning it's kind of quick, but think about when you get to those 5-digit numbers and you're trying to type it in, 15,276 plus 15,000, right? I mean, holy cow. How quickly can I type in 5-digit numbers without making a mistake? Right? I mean, this is going to take me forever. You want to know how big of a number this is? In the history of Sesame Street, right? The actual TV shows they produce started in 1969, and they're still going. They're still making new shows. Cookie Monster, in all of those episodes of Sesame Street, has eaten about 1,500 cookies, right? You're looking at a 51-year career at this point, right? 51 years of eating cookies on Sesame Street, he's only up to 1,500. 40,000 is a gigantic number. So I'm like, okay, we gotta find a different method. So let's go back to the shortest list where there's only 6 numbers and say, okay, is there some other way of figuring out that the answer is 36? Well, there are 6 numbers in the list. I know that. And if I could pair these numbers up, I would have 3 pairs. Right? If there's 6 numbers, I can make 3 pairs. Now, the secret is how I arrange them. I'm going to pair up the 1 with the 11, the 3 with the 9, and the 5 with the 7. By pairing them up that way, each pair has the same total, right? Each pair has a sum of 12. Whether I do 1 plus 11, or if I do 3 plus 9, or if I do 5 plus 7, every single time they add up to 12. I'm like, aha. So if I know there are 3 pairs, and if I know each pair adds up to 12, I know 3 times 12 is 36. Right? So if I know how many pairs there are, and if I know what each pair adds up to, I can just multiply those numbers, and I know what the total is. So if there's 38 numbers in the list, I don't have to list all 38 and add them up. I just need to know, hey, how many pairs? What does each pair add up to? Well, the number of pairs is easy, right? If there are 38 numbers in the list, that's 19 pairs, right? 38 divided by 2 is 19. So I know I can make 19 pairs of numbers. Now, what does each pair add up to? Well, I better figure out the first number in the list, right? So I better take the number 1 and I better plug it in. So 2n minus 1 becomes 2 times 1 minus 1. And of course, that becomes 2 minus 1, which is 1. So the first number is 1. What's the last number? Well, for the last number, I better plug in that 38. Right? Because there's 38 numbers in the list. So if I want the last number, I could go 2 times 38 minus 1. Right? 2n minus 1 becomes 2 times 38 minus 1. And so that becomes 75. Right? So if I paired them up, right, I do 1 plus 75. I do 3 plus 73. I do 5 plus 71, etc., etc. Finally, I get to 37 plus 39. And say, hey, you know what? Every single sum is going to be 76. Right? So I know there's 19 pairs. I know each pair adds up to 76. And the only pair I really need is the first and the last, right? I just need that 1 plus 75. I don't really need the others, right? I say, hey, 19 pairs. Each pair adds up to 76. 19 times 76 is 1,444. And if you look at the top of the screen, I can even put that in as my answer. Say, hey, it equals 1,444. So what I need to know to find the answer is I need to know the number of pairs, and I need to multiply that by the sum of the first number plus the last number, right? Because if I can get the first number and the last number, I know what every pair is going to add up to. So I only need two things. I need the number of pairs, and I need the sum of the first and last number. Okay, so 40,000, right? No way am I going to try to figure this out by adding every single term. So how many pairs? Well, piece of cake. If there are 40,000 numbers, divide that by 2, there are 20,000 pairs. All right. How much is in each pair? Well, plug in the number 1 to get the first number in the list. And then plug in the number 40,000 to get the last number in the list. All right, so 2 times 40,000 is 80,000. 80,000 minus 1 is 79,999. So I know that each pair is going to add up to 80,000. All right. The first number plus the last number makes 80,000. So I know what each pair adds up to. So if I have 20,000 pairs, each pair adds up to 80,000. I can then figure out that if I multiply, I end up with 1,600,000,000. Right? Or 1.6 billion is what that adds up to. Okay, so let's take a look at an example that's a little bit different now, all right? So I was like, all right, got started at 1, and then at the end is going to be 42, right? So there's 42 numbers in this list, and 4n plus 9 is our rule, right? 42 numbers in the list. That means, of course, there's 21 pairs, right? Half of 42 is 21. First number in the list, well, I gotta go 4 times 1 plus 9. 4 times 1 plus 9 is 13. That's the first number. The last number in the list, well, I gotta plug in 42. I go 4 times 42 plus 9. I'd use a calculator. I get 177. So each pair adds up to 190, right? I took the first number, 13. I took the last number, 177. That pair of numbers adds up to 190. So the grand total, 21 pairs. Each pair is 190. Multiply those numbers. I get an answer, 3,990. And so that would be the sum. Now, I got to do a disclaimer. This method only works if the series is arithmetic. Right? Just because I got a list of numbers does not mean this method works, right? It has to be an arithmetic series. Right? If it's not an arithmetic series, this method is not going to work. All right? So a little disclaimer there. But on today's worksheet, of course, they're all going to be arithmetic series. So this method will work on today's worksheet. And I've actually shared this image with all my classes this week. You know, I was trying to do some sort of holiday themes thing. So I was, looking for, hey, how about Santa Claus cow? And I know what a cow is supposed to look like. And I'm figuring that this animated character, or not animated, it's a drawing, right? There's no animation there. But this character, I'm figuring it is supposed to be a cow, but I know what cows look like, and I know what a hippopotamus looks like. And when I look at the nose and the mouth and the ears, I see a hippopotamus, right? So, um, I don't know. I just find this image a little bit bothersome, to say the least, right? And even the teeth on the illustration, I didn't get a good picture of a hippopotamus showing its teeth, but yeah, I don't know. It's just weird. So, uh, time to tackle that worksheet and have at it.